we'll have some more information and updates on that. So Carrie Hicks is back with us from assignment, and so I've asked Carrie to provide a quick update on operationalizing the ORL model, the operational readiness level model. And so, Carrie, I'm going to turn it over to you. I'll give you the screen, and you can walk through that. And we have some freshmen on the phone, so just take a minute and explain ORLs if you get a second, okay?
All right, sounds good, Tom.
Okay, you should have the screen.
All right, can you see my screen?
Yes, we can.
Perfect. All right, good morning, everyone. As Tom said, my name is Carrie Hicks. I'm a senior data analyst at Duke Energy. I'm going to be talking a little bit about how we were able to operationalize the operational readiness levels during Hurricane Florence, which is something that we've been working up to for quite a while. And also, excuse me, I have a little bit of a cold, so I sound a little gross, so I apologize for that. So just a quick overview of what I'm going to be talking about. I'm going to go over kind of a background of the operational readiness levels and also what our goal was with implementing these during Hurricane Florence and kind of what that looked like within our sort of processes. And then I'm going to go over some successes and lessons learned. So for a quick background, we have a GIS analyst storm team at Duke Energy. There's about 15 people on our team from around the company, Florida, Carolinas, and Midwest. I'm actually the team lead for that group, and during storms of a certain size and impact, we get activated. So I was in Raleigh during Hurricane Florence. I was also in St. Petersburg during Irma last year, so they tend to deploy me when the situation is fair enough. So we've been working as a team over the last year and a half to improve our processes, to do data automation, map automation, to prepare for major events on blue sky days. So we've done a lot of work on our end to leverage the Esri portal, establishing best practices so that we're prepared when a major storm does hit. And then speaking to the operational readiness levels, this model has been worked on and refined, I say the past year, but really it's the past several years. But I really only got involved about a year ago on the project because I felt that it was really beneficial and I saw possibilities for implementing it on our end. So I'm going to be talking a little bit about that. But we have an ORL committee within the SITES working group, and we decided to basically do a test of the model in a real storm event. So back in June, we had a storm summit in Charlotte that, we invited our Duke meteorologists to, several folks that are within higher level IC positions. We had the summit and worked through a lot of this stuff, and that's when I officially announced the model and we figured out how to implement it. So that was back in June, and then we actually tested it during Florence. So I brought this up because I think you guys have probably seen this, most of you anyway. This is the ORL model decision tree. The ORL model, the point of it is to quickly and efficiently rank data sets based on how operationally ready they are. So an ORL of 1 indicates that the data set is operational, it's from a trusted embedded source, and it meets these requirements that you see on the left here. So this is, one of those things where we're kind of continuing to work on these requirements, and I'm going to talk about that later with some suggestions for refinement. But as you go down the tree, if you answer no to anything, it lowers the ORL ranking. So the whole point of this is to have a simple way to kind of standardize how operational a data set is and to communicate that to end users who may not have a background in data or GIS or data science. So I'm going to go over on our end the process that we implemented for adding a new data set to our production applications when we're in storm mode. So first you have to find it. Either you are looking for the data set or someone sends it to you. We prefer a REST service. So those are the easiest data formats for us to quickly implement into our application. It doesn't have to be, but that's definitely preferred to have that endpoint already published. We assess the source of the data set. Is it trusted and reliable? And that's obviously subjective, and we're kind of working on, how do we figure out if a data source is trusted and reliable. But right now it's subjective. Hopefully, it won't be in the future. But if no or unsure, we're not adding that data set to our production application. We actually have a test web map that we can add those data sets to so we can look at it later. So that's what we do. We add it to our test web map. Then we add the service as a portal item. So some of you may not be familiar with ArcGIS portal, but once we get that URL link to the REST service, you can add it as an item. We have a naming convention that we implemented. So it starts with the ORL level, then the data source, so NOAA, for example, and then a quick description. We have a metadata tagging process. So we tag the item in portal with the ORL level, the use case, and the ICS section. So we're kind of thinking in a way that use cases should roll up to one of our incident command sections, be that planning, logistics, operations, or finance admin. So I'll talk about that later. I have another diagram that kind of explains that. So we then add a full description of the data set within portal, and we share that data set to our storm group, which is a group within portal. So that's helping us kind of keep track. It's not necessary for adding it to the application. People can still see it, but if we don't share it to the storm group, things get disorganized. We then add the portal item to the web map, and we ensure that the service is working as expected. We set any necessary zoom level restrictions. We check the labels, symbology, so on and so forth. Then we add the service. This is a new step we have an alert site dashboard for monitoring. I'm going to be showing some examples of that, but basically it helps us monitor the performance of external services. And then during storm, one of my jobs was to monitor those services to make sure they're all working. And if it's causing issues, we actually take it down. We're also utilizing splash pages in our web app to communicate to our users that new data has been added, or anytime we change something, we communicate that way. So speaking of what I was just talking about, how our use cases kind of roll up through sections, this is just a simple diagram that kind of illustrates that. So the use cases that we've identified within Duke Energy as being the best for our group to add value to are situational awareness, and then routing, flooding, and base camps or staging, and then outages. So we actually have applications for each of those, but they all roll up to one of the sections, and that's kind of a helpful way for us to make sure that when we're providing solutions that they're actually helping someone. So anytime we add data to one of those apps, we're working with, for example, the logistics chief to make sure that it's in line with what they need. So this is a screenshot from within our portal of one of the data sets. This is actually something we added during Michael. Michael. Yes, I keep wanting to say Matthew. It's too many sorts. But this is a data set that actually came from Esri for Waze Alert. So you're probably all familiar with Waze. We rank this as a 4, partially because it is crowdsourced. I have a description here that's just simple. Tells you where the data source is and how it should be used. And then over here you can see how we tagged it with the ORL level. We tagged it with the use case of routing, and then we tag it with the section name, which is logistics. And I'll say really quickly that, it doesn't mean that a use case is always going to only apply to one section, but it's just a way for us to streamline our solutions a little bit better. So this is a screenshot from our application. CD stands for customer delivery. We used to be 1DF. Now we're customer delivery, so that's what the CD is. But each of those tabs indicates one of our applications. So outage and restoration viewer, that falls under operations. Situational awareness falls under planning. And then flooding, routing, and our base camp tracker fall under logistics. And then in the layer list, you can see all of our internal data sets we label with a DE for Duke Energy. But then all the external data sets are labeled with the ORL level. So ORL 3, 4, 1.
Wow.
That's how we've been indicating that.
That's outstanding. That's awesome.
Thanks. So this is a screenshot from our alert site dashboard. So it's how want to talk to you about this. This is an incredible tool. What it allows you to do is bring in external APIs into the dashboard, and it will actually ping that service at an interval that you choose. So I chose 5 seconds. So every 5 seconds, it's going to ping that service, and it'll give you a response time, a performance, and availability metric, and then this is the average. So, for example, that REST service, the average response time was 1.5 seconds. Some of them are much better, like the base reflectivity radar was 0.22 seconds. It gives you a little graph. So I was using this during Florence to monitor our services because, if a service goes down or it times out, it actually can cause the entire application to stop working. So we have to keep an eye on that anytime we bring in externally hosted data. So you can see the hourly river flow anomaly model. That one you can see had some issues. It was timing out. It was taking a long time. Sure, go ahead.
So this helped you monitor the speed and reliability of the connections to these outside data sources. Interesting. Okay.
Exactly. And if you think about it, on a blue sky day, all of these services are going to be working great.
Yep.
When there's a major event, when everybody wants to see, hurricane tracks and those kinds of data, that we start seeing errors. So it lets us go back in time and kind of assess how those services responded and how they performed during high use.
I got it.
So you can set different locations. So I have the pinging from multiple different locations. And
wow.
It lets you know when there's an error. So, and it actually sends you an email. So I was getting emails if there was a timeout or an issue. So this, I think, needs to be incorporated into the ORL ranking. And we can talk about that in more detail later. But, so speaking to some of the successes, we found the ORL model incredibly helpful on the GIS side of things. So it fit really well within our existing processes, asking our question of, is this data set appropriate for the use case? So we don't want to be in a situation where we're in storm mode, we're under high pressure, we're just adding a bunch of stuff in there. Because that gets confusing for the user, and it lowers the value and the impact of our application. Is it comprehensive, or is it just for one region? Does it make sense to add a data set if it's just for a small area? Should we be trying to add data sets that encompass our entire service territory? And then thinking through naming conventions and all that. So it just fit really well in our existing process. We also found that filling out the form, so there is a form that lets you rank the data, before adding a data set, it really made us more thoughtful and less knee-jerk about just tossing the data in there. So, we actually had an example of the VIRS flood data, which Tom and Dave, you sent that to me. We put it through the ORL model and we ranked it. I think it came out to 3. But the problem was it was kind of last minute, and it was difficult to explain to people. I was trying to explain to Ron Osborne, who's one of our emergency preparedness managers, what the flood data was showing, and it was too much. And we just found that even though it passed the requirements to be ranked at an appropriate level, it was too confusing of a data set to add to the last minute. So we wouldn't have necessarily come to that conclusion if we hadn't gone through the process of ranking it. So incredibly effective, process for us.
That's
so there's
great.
that flood data, which I want to track this moving forward because I found it probably one of the most useful, near real-time flood data sets that I found. So I'm really interested in seeing where that goes. So some of the lessons learned, communication continues to be a challenge. We're actually working on a form that will incorporate information about the ORLs into the map itself, because right now you have to click on an external link to go read about the levels, and it's just not incorporated very intuitively into the application for the end user. So we also just need to work on communicating with users and what the model means. Our higher level people, they have been in the know. They were at our storm summit, so they know what this is. But some of the lower level, like zone level people that were using these apps, they had no idea what the ORL levels were, and it's just hard to find a good way to communicate what it means without doing a training on it.
Yep.
So one of the things I was thinking about doing was putting together a CBT, a computer-based training module that people can access to learn about it. So also there's some tweaks I think we should make. So mentioning that alert site tool, it'd be great to incorporate the REST service monitoring metrics. So a couple of the data sets that were ranked at a 1 or a 2 and would have performed fine during a blue sky day, they kept timing out just because of the number of people using it. And that is something that should affect the ranking for sure.
Yeah.
So, or they, even if they didn't go down entirely, they would slow way down and have, 4-second response times.
Carrie, what is REST? What is REST service? What does that mean?
I'm not sure actually what the acronym means, but basically if you publish a data set to a server, and then that server has access to the internet, you can provide it as a REST service. It basically, if you have an application or another way of incorporating or reading that REST service in, it's an API. So ArcGIS has their own API for REST services. It's just the quickest way for us to get data because it's just a URL link. You just copy and paste the URL link and you add it as a portal item and it's there. But the downside to the REST service model and to the API is that someone else is hosting that data. Someone else has control over, what server it's on and security and everything. So we're kind of relying on whoever that is to make sure the appropriate conditions are in place.
Sure.
So.
Hey, Carrie. This is Dave. I just wanted to say that all this work that you're doing and the feedback as to, hey, this would have been an ORL 1 or an ORL 2, but it kept timing out. That's going to be incredibly important feedback we can give back to that federal agency or state agency or whatever and say, hey guys, your data was ranked as a 1, but it's moving to a 3 because it timed out. And that can give them the justification to go and either get an additional server, get it up into the cloud, or do things like that, because I think they're always looking for that customer feedback for what might improve their systems and processes.
Yeah, absolutely.
That's great. Carrie, this is a great, real world case study. Awesome. Let me open it up for questions for Carrie.
I have a question. I apologize that I can't see what you are showing, but I think you're using ArcGIS Online, is that correct? And creating a dashboard?
We're using Portal, but basically the same thing.
Yeah, Portal. Okay, that's what we use. We use that in the Fusion Center. So this is an internal application for Duke Energy employees?
Yes. Yeah, it's all internal.
Okay.
Yeah.
Okay.
And
your standard naming convention, is that documented? How you determine, I know you were talking about the various feeds, so you look at NOAA, the feed begins with NOAA and Duke Energy is DE. Do you have anything documented?
I do. I have all of this documented as job aids for us internally, but if that would be interesting for you all to see, I can send it out.
yeah.
So, just from my perspective, we are putting GIS into the Virginia Fusion Center, and we already have GIS in emergency management, but I'm already looking. I have a GIS background, so I'm already looking forward to seeing. I can imagine it's going to be difficult for us to share feeds if we don't know what the naming conventions are.
Mm-hmm.
So if you already have something in place, if you would be willing to share it, I would be most appreciative.
Oh, absolutely, and that's also kind of the goal of the GIS committee that Tom mentioned earlier in the call. So once we get that set up, we're going to come together and come up with kind of a best practice for implementing these within your organization. So this is intended to be used externally. This is more of a test bed kind of soft launch within Duke just to test it out and see how it goes. But the whole goal of this is for it to be an industry standard. So, yeah,
Okay,
absolutely.
excellent.
Yeah.
Okay. Hey, Tom, thanks for inviting